And we're looking at 6.1b. If you haven't done 6.1a, I highly recommend that. 6.1a, that video is going to go through some of the prior knowledge that you need in order to do this section, especially looking at the unit circle. So if you're not comfortable with knowing all the unit circle, if you can't reproduce the unit circle right now, I suggest you go back, watch part A, and then come back into here. It'll save you a lot of hassle and heartache. All right, so this first one's saying, let's determine the exact coordinates of P. P has a 45-degree angle. So that means, hey, that's one of the special triangles that we went over in part A. If that's 45, that's 45, because this is, oh, look at that. We're talking about the unit circle, radius of 1. That's 1. So then that gives us the two sides. That was root 2 over 2 and root 2 over 2. Or just looking at your unit circle, we know that we're talking about place root 2 over 2, comma, root 2 over 2. Or if you would prefer, you can use 1 over root 2 and 1 over root 2. I'm going to focus mostly on the root 2 over 2s. There is a method to my madness, which eventually will come out. All right. We want to know, first one, determine the value of tan of 45. Tan of 45 from part A was y over the x. So we're going to take our y coordinate, which is root 2 over 2, and divide by the x coordinate, root 2 over 2. Oh, hey, if we're dividing it by itself, we know that's going to equal 1. Now, going a little bit trickier here. We're going to talk about alpha. Alpha is some angle between 0 and 360. And we're looking for another place where the sine of 45 is equal to, exactly equal to, the sine of this alpha that we've got to find. So we go to our unit circle. Easiest way to do this one. The sine, oh yeah, that was the y coordinate. So we look at our y coordinate and say, okay, that's root 2 over 2. Where on the unit circle is it also root 2 over 2? Exactly. Positive value. Bringing in our cast rule, C-A-S-T, we know that sine is positive in quadrant 1, the A, and quadrant 2 for the S. So that's where we want to look, where it's going to be the same, because quadrant 1 was a positive root 2 over 2. So we're looking for that value on our unit circle, and we say, oh, hey, it's right over here, and that value on the unit circle was 135 degrees. So in this case, alpha is 135 degrees. Or in other words, we're going to 180 and coming back the 45 degrees. 180 minus 45 is 135. The next one, cos. Where is it going to have the same value as cos of 45? Cosine is positive in quadrants 4 and 1. So we're going to look in quadrant 4 for this one. And we're looking for it to have the same x-coordinate. Cosine was the x-coordinate. And the x-coordinate was positive root 2 over 2 as well. So where is the x-coordinate positive root 2 over 2? Oh, that one was where we had 360 minus 45. 360 minus 45, which gives us 315. That could also have been found just by looking at your unit circle and find where is the x-coordinate the same as root 2 over 2, positive. Tan. Tan was equal to 1 because it was the same thing over. In order to be equal to 1, that means the x and the y value have to be the same. And we knew it was equal to 1 from up here. So where else on the unit circle is it going to have the same value, where the x and the y are identical in both number and sign? We know it happened here at 45, but it also happens in the t, the tan quadrant. And that's because it's going to be negative root 2 over 2, comma, negative root 2 over 2. All right, so then where does that happen? That happens at 180 plus 45. 180 plus 45, that gives us 225. So it was y over x, which equaled 1. All right, let's continue with constructing your understanding. Okay, so there's a clock. If you don't know how to read the clock, it says 3 o'clock. And we're saying that this is 3 a.m. right now. Okay, how far is it to go to 3 p.m. that same day? And we're just looking at the hour hand, rotating that. So the hour hand, that's this one, if you didn't remember which one. We're taking it and going from 3 all the way around until it's back at 3. That means it's going to go around once all the way around that circle, 360 degrees. But what happens if I want to go to 9 p.m. that same day? Well, we start again. It's going around until it gets to here. That's 3 p.m. But we got to get that all the way over to 9 over here, so that our hand is pointing to the 9. So that gave us 360 to go around once to get to 3 p.m. Plus it's got to go another half of a circle over, so that's another 180 degrees. It's going to be 540 degrees to get there. 6 a.m. the next day. Oof. Well, we're going to go from here all the way around to there. Oh, let's put, we know that it's got to go down to here. 6 a.m. the next day. That gives us 3 p.m. If we go around again, that gets us to 3 a.m. the next day. And then we've got to go to 6 a.m. Well, it went around 2 full times. 2 full times. 2 full rotations. Okay, so 2 full rotations. And then it went an extra, that gave us back to here at 3 a.m., an extra quarter turn. And then a quarter rotation. Or 2.25 rotations. 2 full rotations, that's 2 times 360, that's 720 degrees. Plus a quarter rotation, that's 90 degrees there. Plus 90 more degrees, that gives us 810 degrees. Now 10 a.m. the next day. Oh, this is a tough one. We need to get our hand is going to be here. Let's go around. That gives us 3 p.m., 3 a.m. the next day, and then we've got to go still further. Change the color to make it easier. All the way to there. So we know we have 2 full rotations. That gets us to 3 a.m. the next day. That's 720 degrees. Plus, we have some more to go. Well, that green part is where we're looking at. From the 3, it's got to go around to the 4. That's 1, 2 to the 5, 3, 4, 5, 6, 7 out of the full way around. Well, we know that to go a full round of clock, that's 12 hours. We're going 7 out of those 12 hours. So we got 7/12 of a rotation. A full rotation 360. So we're looking at 7/12 of 360 degrees. So 720 plus 7/12 of 360 gives us 720 plus 210, or 930 degrees. All right, I think it's time for a little bit there. You may be right, Pythagoras, but everyone's going to laugh if you call it a hypotenuse. All right, so going through all the different parts, just to remind you of all the different things that you learned with regards to the angles from last year. Unlike a clock, the clock rotates clockwise, obviously. When we're doing our trigonometry, we're going to rotate opposite. We're going to go counterclockwise at the origin. So if we're talking 130 degrees, we're going in the counterclockwise direction. That's going to put us in quadrant 2. And that's why they're labeled quadrant 1, 2, 3, and 4. Because when we rotate counterclockwise, that's the quadrant we get into with the terminal arm. Terminal arm is where you stop. Now if we continue rotating that, and you can see there, we're going one full time around, that's 360 degrees to get us back to the positive x-axis, but I'm going further yet. Another 200. So we're going 360 plus the 200. That gives us 560 degrees to get into that second quadrant by going around one whole time and further. Defining your negative angles again. If you travel clockwise, that's opposite to what we usually would like to go. So that's in a negative direction. Negative 130 degrees. Likewise, we could go further than 360 by going all the way more than once around the circle to negative 560 degrees. We're not limited by doing this. We're not limited to just the trigonometry within one triangle from angles 0 to 90 degrees. We can extend it into negative and into things even bigger than 360 degrees by putting it onto our Cartesian plane like this. All of these rules that we're talking about are really the rules for standard position. And we can stop at the same place, coterminal, ending at the same place, terminal is ending, in multiple ways. I could just go 40 degrees straight to there. I could go all the way around 360 plus 40 degrees. Which is giving us the 400. I could go around again. 1, 2 times around, which is 720, plus the 40 degrees. This 40 degrees that we're showing here, that has a special name. That right there is our reference angle. But we could also take it in the negative direction. Same thing. Going around backwards. Really what's happening here is we're going 360, but went too far in the negative direction, coming back 40. So negative 360, and then come back 40 degrees. That's how we're getting this negative 320. Same thing with the negative 680. 2 times around, that's negative 720, but went too far, come back 40 degrees. Again, that 40 degrees is still the reference angle. And it says there are an infinite number of angles that are going to be coterminal. We could go around, positive, negative, as many times as we want, and return to that same spot. So then into your bit.ly link. Well, which ones of these are coterminal with 25 degree angle? This next concept is extremely important when we talk about something called the general solution. And we're going to be dealing with this quite a bit in this course. So our general solutions means how often is it going to keep happening if we go to infinity? And I'm going to change it up slightly from the variables I use. Okay, so the measures of positive angles that are coterminal with 40 form an arithmetic sequence. We go 40, then 400, then 760, and on and on and on. Where that general term is really what we're doing is we're adding 360 to 400, or sorry, to 40. So we go to 40, and then to get to this point again, P, I'll use different colors in red. If that's 40, I can go around 360 and get back there. I can go around another 360 and get back there. I can go around another 360 and get back there. As long as I've stopped there at 40, the reference angle, it's going to take 360 or multiples of 360 to get back there. And the change I'm going to make is this. I'm going to say 40 plus 360 n degrees. The k, I just prefer to use the n. But here's the kicker. That n is only going to be a whole number in the positive direction. If we go in the negative direction, again, I go to the 40 degrees to get to this P spot, and then I can go backwards, negative 360, or another negative 360, or another negative 360, and it's going to keep getting me back to here. So which gives us 40 degrees, the reference angle, minus 360 with an n. I like the letter n because it works better for saying any multiple of 360. The variable you use really is irrelevant. On the diploma, they like to use n, so I'm going to use n here. So we're saying 40 plus any multiple of 360, either positive direction or negative direction. So I don't need a whole number. I could talk about integers. So the change that I'm going to make here is 40 plus 360n degrees, where n is an element of integers or z. Z is also for integers, either the I or the z. I usually use the I. All right, let's look at all the things, all the angles that are coterminal with 85. That's a key one there. Let's highlight that. And we're going from negative 800 to positive 800. 85 degrees. That is our reference angle. So I'll write it like that. Reference angle of 85. Let's do a quick little sketch for ourselves. I know that 85 degrees is going to be somewhere in quadrant 1, where that's 85 degrees. And I want to be able to go around positively however many times I can until I hit 800 degrees. I can't go past 800. Or negatively around as many times as I can until I hit negative 800. Can't go past negative 800. So let's check her out. I could go 85 plus, I better put the degree sign, plus 360 degrees. Adding those up, that gives me 445 degrees. That is less than 800, so that's a good one. Let's go another 360. I could add 360 to 445, or I could go 85 degrees plus 2 times 360 degrees, which is really 720. 720 plus 85 degrees gives us 805 degrees. Whoa, but wait, I can only go up to 800 degrees. That's a no-go. That's past where I'm allowed to go. So the only other positive answer is 445. Let's do the negative ones. I could go in the negative direction. 85 degrees, we're starting at our reference, and go backwards 360 degrees. Better put my degree signs. 85 minus 360 gives us negative 275 degrees. That one is good because it's between negative 800 and 800. Let's go a second time around. We go a second time around. That's 85 minus 720, which gives us negative 635. That's still between negative 800 and 800. That one's good. So those are our three angles coterminal between 800 and negative 800. Next part. Write an expression for the measures of all angles. And really what we're talking about there is kind of an XER. All the real numbers, if that's our domain, that are coterminal with 85 degrees. Well, we got a cookie cutter here. Reference angle, which is our 85 degrees in this case, plus. We're going to add to it any multiple of 360 degrees, because I can keep going around either positively or negatively, counterclockwise or clockwise around. So I'm going to be able to add to it 360 n degrees. So I'm going to add 360 n degrees. But I've got it, you have to define that your n is an element of the integers, or the z. So there's my answer. Here's your cookie cutter. That will work for all of them. Find your reference angle, the first positive answer. That's really what I'm looking at. The first positive answer plus 360 n degrees. So now we start talking about putting triangles onto the circle here. If we make a triangle there, we've got an x-coordinate, we've got a y-coordinate with a radius of 1. This is the unit circle that we're going to be describing here. So if I use this x comma y, it's going to give me x squared plus y squared equals 1 squared, which is just x squared plus y squared equals 1. The radius is 1. And that would be for any point. And that point could even be in quadrant 2, 3, or 4. As soon as you square it, they're going to be positive. X squared plus y squared equals 1 for every single triangle all the way around. And it doesn't matter where we are, where we're putting it. It's every single one of those triangles all the way around. If we put all those triangles and all those points together, we get the full circle. We get all of the points of the circle. So what actually happens there is we've just developed the equation of the circle. The equation of the circle is just finding every single point, all the infinite number of points, using Pythagorean theorem for every point all the way around. X squared plus y squared equals r squared. And reminding you of the concept that I brought in the first part of the video, is that your cosine is really x over r, so that your cosine in the unit circle becomes the x-coordinate. Cosine is the x-coordinate, sine is the y-coordinate. And your tan is y over x, or the rise over run, the slope. Tan, the tangent, is the slope of the line on the unit circle. Cosine, sine, tangent. And just remind you, if you need to, SOHCAHTOA. Even though we're not going to use too much of that in this course, because we're not going to talk about opposites and adjacents very much. We're going to talk about x, y's, and r's. Those are called our primary trig ratios. By calling them the primary, that must mean, there's got to be a secondary set. That secondary set has a special name. We call them the reciprocal trig ratios. The reciprocal trig ratios are obviously the reciprocal of the originals. Cosine, the reciprocal is the secant ratio. So secant is 1 over cosine. Cosecant goes with sine. So cosecant theta is 1 over the sine of x. And tan goes with cotangent. Cotangent theta is 1 over tan theta. How are we going to remember that? The tans go together. Tan and cotangent go together. Then we've got an S going with a C and a C going with an S. All right, this next part is not in your book. However, there's a nice space at the bottom of 470. We're going to use the unit circle to be able to answer all 6 of the ratios now. So for instance, let's look at an example of 60 degrees. The 60 degrees is your reference angle for quadrant 1, quadrant 2, quadrant 3, and quadrant 4 answers. Or in other words, reference angle is 60, 180 minus 60 to get into the second quadrant, 180 plus 60 to get into the third quadrant, 360 minus 60 to be in the fourth quadrant. Let's just look at quadrant 1 to start with. In quadrant 1, from the unit circle, 60 degrees was 1/2 comma root 3 over 2. We need all 6 of our ratios: sine, cosine, tangent, and the reciprocals. Cosine is the x coordinate. So we'll start with that one. The x coordinate was 1/2. The reciprocal is secant. Take the reciprocal of 1/2, that gives me 2. Sine. Sine is the y coordinate. Cosine was the x. Secant is 1 over x, the reciprocal of the x coordinate. Sine is the y. Cosecant is the reciprocal of that. So I go to the y coordinate, root 3 over 2. Cosecant, flip it, 2 over root 3. Tangent. Tangent now is, again, the y over the x. And because the denominators are always the same, you just have to look at the numerators. Root 3 over 1. That's tan. Take your cotangent, it's x over y. Or flip that value, 1 over root 3. And bringing in our cast rule as well, all the primaries are going to be positive. So if all the primaries are positive, when we take our reciprocal, all of the reciprocal ratios will also be positive. Into quadrant 2. That's 120, or 180 minus 60. So that means there's actually 60 degrees inside. We made a triangle there. From the unit circle, we know it's negative 1/2 comma root 3 over 2. And we go through the same thing. Cosine is x, negative 1 over 2. Flip it, gives us secant. Sine, the y value, root 3 over 2. That's positive. Flip it, 2 over root 3. Tangent, 3 over negative 1, or negative root 3. The only one that's positive for your primaries is your sine. And also its reciprocal, which would now be cosecant for the reciprocal one there. Then we've got in quadrant 3. Same thing, cosine x value, secant flip. Sine y value, cosecant flip. Tan y over x. cotangent, flip x over y. The only original primary that's positive is our tan. And also its reciprocal is going to be positive. And then in quadrant 4, 300, because it's 360, coming back 60 degrees. Put that 60 degrees inside that triangle. And I'll put 60 degrees inside this triangle. 360, that's too far, coming back 60 degrees. Gives me the 300. And the same thing. Going through the x, the y's, and the y's over x's. The only one of those that is positive from the primaries is cosine, and it's reciprocal. So see, and that's again where we get the cast rule from. Okay, so as soon as they say determine the exact values, that means we got to go to the unit circle. You pull out your unit circle, you have it sitting there in front of you. And we're looking at 420. Well, where is that? We know we're going in the negative direction, so that is clockwise. That's 360 negative. But I still got to go further. How much further is what we want to know? Let's go negative 420 minus a negative 360. Leaves us with a negative 60 yet that we have to go. So I got to go 60 further. Puts me here. So I went around negative 360 and an extra 60. Let's make a triangle there and say, okay, where are we at on our unit circle? We went negative 60, but that's coterminal to going around in the positive direction by 300 degrees. Or in other words, 360 minus 60. Let's look at that. What are the points? From the unit circle, we've got 1/2 common negative root 3 over 2. We know it's going to be positive because our x is in the positive direction and our y's got to be negative. It's in the negative direction. And now we just read it straight off of there. Let's do our 6 ratios. Cosine of negative 420 is equal to the x value is 1/2. Done. That's all we got to worry about. Hey, how about our sine of negative 420? Hey, that's our y-coordinate. Negative root 3 over 2. Tangent. Tangent is the y divided by the x. And we only need to look at the numerators because the denominators are always the same on the unit circle. So we've got negative root 3 over 1, which is negative root 3. Let's do our reciprocals. The one that goes with cosine, c, is the one with the s. Secant. Secant of negative 420 is just the flip of cosine, which is going to be 2. Sine has an s, so the reciprocal is cosecant of negative 420. And we flip that one. It's still negative. Negative 2 over root 3. And then we've got tan. That goes with the other tan, which is cotangent of negative 420. And that's just the flip. So it's going to be negative 1 over root 3. All right, now we're going to do 586. It says approximate value. So that's because it's not on the unit circle. So we're just going to have to use our calculator technology to be able to do this. But let's start the same way. Let's start sketching it. We're going the positive direction. That's 360 degrees. But how much further do I got to go? 586 minus 360 gives us 226. I got to go yet 226 more. That's 180 more. A little bit further. So I'm going to be somewhere in quadrant 3. Let's make a triangle out of that. We're going to do our 6 ratios. Cos of 586, our sine 586, our tan of 586, and then our reciprocals. Our secant goes with, and our cosecant goes with sine, and our cotangent goes with tan. So we could just punch it straight into the calculator. You could say cos of 586 or cos of 226. You'll get the exact same answer. So cos of 586 gives us negative 0.6946. Hey, we know it should be negative because of the cast rule. The only one of those primaries are going to be positive is tan. Sine. Looking at that one, well, that's going to be negative 0.7193 plugged into your calculator. I should put ... after because they go on forever. Tangent. Tan of 586 should be a positive number, and yep, it is. 1.0355 ... Now, there's no reciprocal ratio button on your calculator. There's no secant. You need to go 1 over cosine. So 1 over cosine, plug that into your calculator, 1 over cos 586 gives us negative 1.440. 1 over sine of 586 gives us negative 1.390. And then 1 over tan gives us 0.966. In your Math Excel account, if you go into there, and if you go into the textbook, there is an animation that goes through their example. So if you did not understand what we did right here, go through their section, or question number 2, there on the Math Excel. I'm not going to play the animation today. And now it brings us to the equation of any circle that's at the origin. For the exact same reason as the unit circle, we got x squared plus y squared equals r squared. And you've got all of your relationships. We cannot just say, if it's not the unit circle, we cannot say that cos is the x value. It's the x value divided by whatever the r is. It only worked for the unit circle because r was 1. And into your bit.ly link there again in answering this question. You've got to be able to identify the equation of any circle that's centered at the origin in this course. Okay, so pick off which one it's going to be. So you're going to have to be able to get the ratios, any one of the 6 ratios, from a point. If you're given a point, you have to find all the relationships. This is our x value, that's our y value. Okay, so let's start with doing a quick sketch. And we've got it at -1 and -4. I don't know, somewhere's down there, it doesn't really matter. As long as you have it in the right quadrant, it's all that matters. -1, -4. Hey, we need the r value. You're always going to have to find the third side. Let's figure out what that is. So r squared equals x squared plus y squared. -1 in bracket squared plus -4 in bracket squared gives us 1 plus 16. R squared is 17, so we've got r equal to root 17. Now when you take the square root, it's either positive or negative. But in this case, r is representing the radius of a circle, must always be a positive. The other 2 side lengths can be positive or negative, depending on the direction. R must always be positive. Make a note of that for yourself. And let's throw down all the ones. Cos of theta is equal to the x over the r. So negative 1 over root 17. You can leave it like that. Hey, we're right here. Let's do our reciprocal. Cos goes with secant. So secant of the theta. Remember, that's the symbol theta, and I'm doing the written version of it. Secant theta is flip. Root 17 over negative 1, so negative root 17. Sine. Sine is y over r. The y is negative 4 over root 17. Let's do the reciprocal. Cosecant of that angle is going to be root 17 over negative 4. Tangent. Tangent is y over x. So our y value is negative 4 over our x value of negative 1, which is just negative 4. And, positive 4. And do our cotangent at the same time, which is just flip it, which would be 1 over 4. Okay, so they're now giving you a trig ratio. They're saying secant of theta equals 4. And they're also telling you a second piece of information. So they either have to, they always will have to give you two pieces of information in these. It could be the x and the y coordinate. Then we can find the r. Or they'll give you one ratio and they have to tell you where. Well, secant, we can't deal with secant too much. Let's change it. Secant is really the same thing as cos reciprocaled 1/4. So now we're looking at the cosine being 1 over 4. That's a positive value. And between 0 and 180, using our cast rule, cosine is either positive in quadrant 4 or quadrant 1. But we're not allowed to use quadrant 3 and 4 because it said from 0 to 180. So we're only looking at the first two quadrants. The only quadrant where cosine's positive is in quadrant 1. So we're dealing with a quadrant 1 triangle here. We know that cosine is x over r. So hey, our x is equal to 1, our r is equal to 4. This is now the same type of a question as the last one. We need the y value. So we've got 1, we've got 4, and now we need to find our y. Y squared equals r squared minus x squared. Every time we're going to be doing the same thing for these types of questions. That's 4 squared minus 1 squared gives me 16 minus 1. That's y squared. Y squared is 15. So y is square root of 15. But it could be positive or negative. So I have to look at my drawing to decide, am I using positive root 15 or negative root 15? The y value could be positive or negative. And, oh, we're going up, so it's the positive version of it. Put that on there. Now I can do all of my 6. Cos of theta, I know what that is. That's 1 over 4. And the secant, I know what that one was, and that was 4. They gave it to us, so we need to do the other ones. Sine of theta, y over r, root 15 over 4. Let's do our reciprocal. Cosecant goes with it. Flip it. 4 over root 15. And tan. Tan is y over x. So our y value, root 15 over 1. That's just root 15. And cotangent, flip it, 1 over root 15. All right, now we got to find out how many different places could this occur. We're now not bound by the 0 to 180. We're going from negative 360 to positive 360. We're allowed to go one time around positive and one time around negative. Let's draw that. We've got cosine equal 1/4. Cosine is positive in quadrant 1, as we just did in the first part, but also in quadrant 4. So I'm going to go in the positive direction first. Starting at 0, we're going to start driving my car. I start here, I start driving, oh, boom, ran into a tree right off the bat in quadrant 1. Where'd you run into the tree? That's what we need to find out. Well, the way we find that out is either looking on our unit circle. Is 1/4 any x coordinate on the unit circle? No, it's not. So then we're going to have to use technology here, and we're going to do theta equals the inverse cosine of 1/4. And just as an aside, we're always going to be using the positive value because we're going to be looking for a reference angle. And that gives us about 76 degrees. So inside this triangle is 76 degrees here. Inside this triangle is 76 degrees. We're going to go in the positive direction, which is driving counterclockwise. So again, we're driving, we're going counterclockwise, boom, we ran into that tree at 76 degrees. So our first answer is 76 degrees. Our next one, we're going to keep driving, bang, we run into another tree. Where did we run into that one? Well, that is also a 76 degree inside the triangle. That's 360 minus 76. So the two positive direction ones are 76 degrees and also 284 degrees. But wait, there's more. We can go in the negative direction now. We only talked about going from 0 to 360. We got to go the other side from 0 to negative 360. Let's start rotating the opposite direction. So again, I start at my positive x, and we start traveling clockwise. So we're going to go in the negative direction, which is clockwise. And here we go, driving, bang, we run into the first tree there in the negative direction. That was negative 76 degrees. And then we keep driving, going around, and then bang, we run into it here again. That's going to be negative 360, and then come back 76. So we've got negative, oops, do it in blue, negative 360 minus a negative 76 degrees, which gives us a negative 76 degrees and a negative 284 degrees this time. Our final answer, put them in order from lowest to highest. Our four answers now are negative 284, negative 76, put degree signs in there, 76 degrees, and 284 degrees. If you wanted to, you could put plus and minus 76, plus and minus 284. All right, so that was a fairly intense lesson. Good luck with that. Answer these two questions here.